Hey guys, I wanted to do a review on my Portage and Main wood boiler, outdoor wood boiler. I picked up this unit the beginning of 2019 at the Kentucky Farm Machinery Show in Louisville, Kentucky. They're actually manufactured in Canada, and I called and spoke with Brian, who's the owner, and they just so happened in 2 weeks they were going to be going down to Louisville to do the farm machinery show and have a couple models on display. So I got lucky there. So I picked up this unit. It was only about a 30-minute drive for me, and I kind of sat on it for a year. Doing a new construction. I've just finished my house, and I've been planning on doing a wood boiler for 3 years now. And so I just got it wrapped up about 15 minutes ago. I haven't even started the first fire in it yet, so I wanted to do a video kind of overviewing the things that I've gone through to get to where I am right now. So I'll show you a little bit about this unit. This is not a gasification unit, but it is more efficient than just the standard firebox surrounded by water. So I do like that they have they've got an exterior door just kind of protect everything from the elements. Although, as you can tell, I do have mine under a woodshed. So this is just an open building. I'll show you that when we pan out in a minute. And I built this, it's 27 by 40, and I did concrete floor on half of it, and essentially built this building only to season firewood to feed this boiler. So I built the woodshed about a year and a half before the house even. Trying to plan ahead and have several years of seasoned firewood ready to go. So as you can tell, there's two doors here. The main door, really nice CNC cut pieces, you know, for the latch, the way the latch works, the hinges, everything on this is done really well. Did quite a bit of homework before selecting this particular unit. I looked at Central Boiler, Woodmaster, several different manufacturers, but there's a few things that I do like about this unit that made me make this decision. So inside, the water jacket doesn't actually go below the fire, and so this unit is modular, meaning you can take apart and replace or repair different components in the future. So that being said, inside, the bottom is lined with refractory brick, which is going to really push the heat up, and that's where we want it anyway. And then at the bottom there's a shaker grate, and I'll show you this here shortly. But at the bottom the ashes will go through and they'll come out the third door at the bottom, and there's an ash pan. So there's a lever over here. This will oscillate the bottom of the firebox, and the small ash will fall down into a pan. So you can take the pan out and dump that rather than trying to scoop out coals and that sort of thing. So anyway, yeah, it's really nice to take the ash out in the bottom, or at least I think it's going to be. Anyhow, main door, load the wood in. And this, I'm going to guess, I haven't put a tape on it, but I'm thinking it's probably 18 tall and maybe 24 wide, maybe 22. So it'll accept a pretty big piece of wood. So pretty much I'm thinking anything that you can fit in the door, it's going to eat it, no problem. And then in the top, once the heat is extracted once we've extracted as much energy off that hot gas and heat as we can, and the exhaust is going to come up, and this makes a big horseshoe bend. So the exhaust enters in the back, and then it comes up one side, and there's a division in the middle, and it comes up one side and it makes a U-turn and goes all the way around, so that there's more time to take heat off of that exhaust gas before it actually goes out the chimney pipe. So I'm going to show you this, and then kind of how the pumps and things are set up. So the lighting is not great in here, but you can see the refractory brick at the bottom, and then the black portion is where the water jacket begins. And then also in the bottom you can see the shaker grate. I'm trying not to block the view too much. So from the outside you'll be able to shake these ashes down. And then I'll show you in a minute, but in the back right there, there's a pipe coming in. So when the unit calls for heat, when the temperature gets lower, it's going to feed the air underneath the fire rather than blowing it on top, which is a big efficiency thing. So also, you can notice there's a half moon portion that sticks down in the back. Now all the heat's going to get trapped in front of that, and it has to cool down to go under, and then up in the back the exhaust goes up under that. So just to make the heat retain inside the firebox as long as possible. So then again, refractory brick, and then the water jacket does not go, well, it stops before the refractory brick. And then the doors, it's really nice. I'm excited to see how this performs. And again, what I was saying with the all the welds and things are nice, and these parts are obviously cut out on a plasma table or water jet or something like that. So, and that handle locks in pretty nice. It's got it's almost like a two-stage door. So if you open this and there is pressure built up, it can't slam open on you because it's caught in this little latch there. So then you have to make a second movement to pull it out to open it on up. So, and then it cams over. Sorry for the not being focused there. And then this guy, and you can see this is the exhaust side that goes out the chimney, and then as the exhaust gases come up, they'll come up on this side, and you can see that divider there in the middle, if I can focus it well enough. And then this door right here is this access is just to clean that ash out if there's any fly ash that builds up in there. And they give you a pretty long tool there. So anyhow, that's the front of the Portage and Main. Water level is added. Well, this is the initial fill area, so this is a float. I need to add a little bit. I would like to have that a little bit higher, but I've been purging air out of the system for a while, and I'll show you that shortly. And then the back of the unit, another cabinet door, which is nice, just to keep all of the rain and whatnot out of the unit. And then in the back, we have two ports at the bottom, one here and one over there, and then the two ports at the top. Now, I will say, when I originally thought about this, I thought, well, the hottest water inside the water jacket will be at the top. The supply needs to be the top, and the return needs to be the bottom. But to get everything mixed properly, I've been talking to some guys that had set it up this way. So they're pulling water from the bottom, and then the supply water goes in the top, and it mixes it better. So I'm going to give this a shot and see how it goes, but this is how I'm setting it up originally. So when the system does call for heat in the aquastat, this is the A421 Johnson controls, and then the backup right here. So these controllers you can get at like any Granger, pretty much any HVAC supplier. I think they're mostly used for like refrigerators, walk-in refrigerators, freezers, things like that, but they do work well in this scenario. And I'm using this one that's on the unit, and I actually have another one in the house, and I'll show you that too. So when the system calls for heat, it's going to turn, the aquastat is going to turn this fan on, and then the fan blows air on the fire. So I wired in this pump to run all the time. It's actually running right now. It's a little warm to the touch, but it's not, I can feel it running, but it's not hot. Anyhow, I want that pump to circulate all the time. I do have a breaker that I can switch to turn this off, but you're not going to accidentally turn this circulation pump off, because I did not add glycol. I did add the rust inhibitor to the water in the system, but I did not add glycol. I plan to run this circulation pump all the time. And then this switch here, when you flip it on, it's not going to do us a lot of good right now, but it will show us on the aquastat that the water temperature is 60 degrees, and it is going to turn this fan on because it's telling the system, hey, the fire needs air. And the damper opens in here as that fan kicks on, and it's adding air to the bottom of the firebox. I'm going to go ahead and turn this off because we don't have the fire going right now, so that pumps, or that fan's us running for no reason. So supply and return. I guess that's really a good segue into the next part of this. I have the pipe that I decided to run from the boiler to the house is the Dual PEX Flex, and it's made by a company in Denmark, and it's definitely one of the more expensive ways to go. Yeah, Logstar, I'm not sure exactly how that's pronounced, but anyhow, I found a dealer in Ohio that sells this. It's actually a central boiler dealer, and I measured several times from where I knew the unit was going to be to the entry in my house, and it was 118 feet. So I purchased 120, and I put this in before the house was even completed. So I'll kind of show you with my finger here the route that it goes, and then I'll add some pictures. But so it comes down, it goes down about 4 feet, and it's so difficult to turn this stuff. They say it's Dual PEX Flex, but it's very rigid. Anyway, I came down and made a pretty much a U-turn around the building. So that tire on that truck is sitting actually on it. Excuse the mess, I'm just now getting all this stuff wrapped up, but it goes straight across through here. You can see that is plumbed up too. So I ran electrical conduit when I had that trench opened up, and so it runs all the way in underneath that deck into the corner of the house right there. While I had that trench open, I ran 1 inch conduit and a 1.5, and I'll tell you why. So hopefully, if you guys plan on doing this, you can avoid a couple of the mistakes that I made. So my 1 inch conduit comes up right here, and I'll put in a sub panel. The reason I have this junction box and my concrete cut out is I decided to run 6.3 out here so I could have 60 amps and have and be able to power other things rather than this pump. But the wires I cut weren't quite long enough, and that's where they stopped. So I had to add in that little sub panel, or this little junction box down below, and then shoot it on up to here. And then I added some lights, which you can see that over there, and there's the switch. So I don't want to be able to, come out, and if it's night, I don't want to have to load it in the dark. So I wanted to add in a couple LED floodlights, and then the 1 inch conduit coming down from the sub panel, or one of the three. One is the supply, the other one is going up into the boiler, and eventually I'm going to add a concrete pad over there for like a automotive service thing, but this is just an extra piece of conduit there for that. And it runs underneath this little pad here. I added an outdoor spigot. That was part of while I had the trench open, I added that as well, which would be nice to fill the top of the boiler with water, but I'll show you. I didn't do that, and then here's my firewood before we go in the basement. So I've got 2 full bays. This is 9 feet. This bay is 9 feet post to post, and this one's just over 10, and it's filled halfway, and I've got quite a bit more kind of sitting out. I've got years worth of firewood, so I'm pretty stoked about that. So I'll show you where all that runs to. So, and again, that pipe goes in the house right here, which is in the corner of the garage. I'll show you that. Again, you'll have to excuse the mess. I'm not fully moved in yet. So, other end of the dual PEX flex, I just came out as low as I could in this garage. They supply these couplers because this is a 1-inch ID. The American Shark Bite brand 1-inch PEX, any 1-inch PEX is not, it's not the same. So you'll have to have these special connectors, which they had at the supplier for this dual PEX flex. So they do give you a cap to put on there, and I got in a rush because I was really stoked about getting it hooked up, and I forgot to put the cap on. So it'll be fine. I'm gonna build a chase around this anyway. So I tried to go few connections as possible. So I ran this solid across the top of the ceiling in the back of the garage. And again, I will build a chase around that so nobody will see it, but it's not even that big a deal. So it goes in there. So it comes out, continues on around, still no connections, up and over to my utility area. Now this stuff, it looks like I just kind of made a little bit of a mess, but those rolls are so stiff running that 1-inch piping. All right, so now this is gonna be kind of a shocker, but my supply line comes in here, and I ran into a Dragon brand plate heat exchanger. Now this is a 50 plate heat exchanger, does 100,000 BTUs, and I'm gonna be able to bypass, I built in bypasses for everything. So I can send it through the heat exchanger, or if I'm having issues, I do recommend using unions on all your connections so that you can take these off and service the thing if you need to. So anyway, right now my hot water, that's actually not hot yet, is gonna flow in the bottom, and it's got a diagram on the front of it, but it's gonna flow in the bottom, out the top. And then I put in a temperature gauge right here, but I did a better one. This is not as accurate as I want it to be, but this is the supply from the boiler, and then it goes, so domestic hot water first, and then this line runs over to the furnace, and I have a heat exchanger that I put in. I haven't taped that down yet. I had a leak and I had to fix it, but I put in a heat exchanger in my plenum, so I've got hot water. I'm just gonna leave that for now, it's no problem. And again, I did have a leak on this sweat fitting here when I flooded the system, and it was really nice. I just blocked everything off, and I could still let my circulation pump run. And then, so once it goes through the heat exchanger for the plenum and the forced air, it goes back up and over. And this is another thing that I decided to do. So this is the return after it goes through the plenum. It comes down here. Now there's a series of valving, and I got this off Central Boilers, some schematics. And I did a lot of homework on all the different types of ways people set it up, and I did the best I could with it. But you know, I'm hopeful that it's going to function the way I want to, but if I need to make some changes, I can. So hot water's coming in after it goes through the forced air. It's coming down, and some of it is going to continue straight down, and this is the return on back to the boiler. And some is going to get drawn in by a secondary pump that goes down and around into a mixing valve here, and then this pump is pushing water over into my in-floor heating. Now, before the house was built, I did a vapor barrier. I added 2-inch polystyrene foam and hog wire mesh, and I put these 8 loops that you can see going down here. I put these 8 loops 1 foot apart, and all of my zones are between 140 and 180 feet. So it flows through the floor, comes back out, and then some of the water is going, the mixing valve is going to recycle some of the cold water, and then some of it gets cycled back, and it goes back into the system. I did put a T strainer, and so any particulates in the system, I can lock off the valves up here so I don't lose a ton of water, and I can take this bottom plate or this cap off, and then any solids that were flowing through, this has a metal screen inside it, and yeah, the solids will come on out. And then I put in a drain here, which I'll put a water hose connection or something on there in the future. And then again, to take this off, I needed to be able to stop it from backflowing and flooding out too much water, so I put another ball valve here. That is one thing I will say, when you go to set these systems up, you're going to need more ball valves and more fittings than you anticipate, but that's cool. It's fine to set it up to where you can bypass, because if you do have a problem, it'll be a pain in the ass not to. I put these flanges everywhere I could, so that way I can turn this off and service the pump if need be. And then I just ran out of I bought two 100-foot rolls of red 1-inch, and I only needed like 20 feet, so I did some white, which I didn't like doing, but it is what it is. It's not gonna hurt anything. So I'll talk about the controls just a little bit. This is almost fully set up. Here's the second Johnson Controls Aquastat. So what this one is going to do is, right now the water temperature that it's reading, and the probe is not actually in, and so there's a slight discrepancy between this number and the number outside, and that's okay. But this gray wire is the temperature probe, and I have it strapped to this pipe, so it's not getting the most accurate reading, but I tried to make it as close as I could. So this is measuring the water as it comes in the house. So as the water is flowing through the system, what this controller does is, and I'll show you where it says, this is SP is set point. So my set point is, that's actually a differential. So my set point's 100. So if my water temperature in the boiler is at 100 degrees or more, this controller is actually controlling a couple of these relays inside the air handler. So what it'll do is it will not allow my heat pump to function when the thermostat upstairs calls for heat. If I have 100-degree water temperature or more, it won't let my heat pump kick on. It will only operate the fan. So it's just closing a circuit. This is operating a switch. So if my water temperature drops below 100, then what's going to happen is it'll close those circuits and it'll allow my heat pump to function as normal. So I don't have to have two thermostats upstairs. A lot of people will put one thermostat over another, and I chose not to go that route. And then this relay here, I can do it automatically or manual. This is just saying, hey, the water temperature is proper. And so this thermostat here, now, yeah, I know it's a little confusing. It can be. This thermostat here is only for the basement floor. So right now it's 66 degrees in here, but I've got it setting on, let's say 73. So at 73 degrees, this is not satisfied. So you'll see it says heat is on. So when this thermostat is not satisfied, it's turning my circulation pump to the floor on. When this thermostat right here is satisfied, it'll turn that pump off. So then my water will just flow on through and get returned. I don't want the floor to eventually heat up to the same temperature as what the boiler water is, because that's just too hot. So that's the way I decided to go about that. I still need to add a transformer in here for this to work, for this relay to function in automatic mode. So right now it's in manual, and I just close the circuit. So I can turn that pump off. You can hear it there. I turn that pump off manually, and then when I turn it back on, you might be able to hear it as well. Yeah. So anyway, that's the way I've got it all set up. So I've got two of these aquastats, and again, this one is just controlling it actually controls the relays, and it will just send a 24-volt signal to the air handler, and when that happens, it's saying, hey, if the water temperature is over 100 degrees, it's gonna disable my outdoor heat pump and I don't have to use electricity. In the event that I don't feed the boiler and I go out of town or whatever happens, this senses the water temperature dropping below 100, my heat pump will kick on like normal, and my main circulation pump will still continue to circulate, so I won't have to worry about any freezing issues. So again, I'm about to fire this thing off and see how it goes, but also, before I forget, there's a lot going on here, but that hot side out of the water heater, as it comes up, eventually my hope is that the water that's going in, it's going to get heated. There's video on alternative heat supply, I believe, online, and this is how they recommended to set this up. I'm a little skeptical, but I'm going to try it. But I'm hoping that the water in this tank will reach much higher than 130, which is what it's set at now. So if I do get those temperatures of, say, 180, my hot water would then like burn you. You know, having kids washing their hands and whatnot wouldn't be good. So adding in, as the hot water comes out here, adding in a mixing valve for that hot water. So when the boiler is running, it will mix it back down to the, say, 130, and it'll send it on up your hot water line. When the boiler is not running, then it really doesn't matter. I've got this bypass here. So when the boiler is running, I'll be able to just close this bypass. It'll force all of the hot water through the mixing valve. And then when I don't run the boiler in the summer or whatever, I'll just be able to open that up, and I don't have to mix that here. I also have a valve over here to close off that cold water supply so that I don't have unnecessary cold water diluting my hot water. And then lastly, on this white line is my return back to the system. I teed off and connected and put in a ball valve in the middle back here. So whenever I need to add water to my system, and I do need to add a little bit, so I can add some water to the system, and I'm not going to add much, but hopefully that added a little bit out to the that float, made a difference, but it easily can overflow it, so I'm not going to go too much. So anyway, that's how I filled my system. I didn't have to carry a hose out there. I can just add in. And the reason that works and you don't contaminate your potable water is this pressure on the boiler is only, even with the pumps running, it's only running a couple pounds of pressure, you know, maybe up to 10. And the pressure on the water coming in from the street is higher than that. So when you open that valve, it's going to push water into the boiler system, and then you close that off and it's no problem. So anyway, that is my system, and I'll show you another video when I get that fire rolling.